This is a practice video to remind you on how to solve kinetic energy problems. We'll do a few problems together on paper, and this should help you to get ready for the post-test and to complete all your Lesson 3 PE and KE problems. I'll do a second video separate from this one on the potential energy problems. So let's start out by reading a problem together and writing what we know. For this example problem, I'm studying a roller coaster that has a mass of 1,000 kilograms and a velocity of 50 meters per second, and I want to solve for the kinetic energy. The first thing we want to do is write down what we know. The mass of the roller coaster is 1,000 kilograms. The speed of the roller coaster, or the velocity, is 50 meters per second. And the kinetic energy is our unknown. So sometimes students have a hard time finding out what the numbers in each problem represents. This is where your cheat sheet comes into play. You can go back to the front of your Lesson 3 notes packet and you can see that if you see kilograms, that means mass. If you see meters per second, that means velocity. And everybody should know that kinetic energy is always measured in joules. So our second step is to write the equation. Okay, so the equation that we use for kinetic energy is KE equals mass times velocity squared divided by 2. Okay, step 1, write what you know. Step 2, pick the right equation. Step 3 is going to be to plug these numbers into this equation. So now I'm going to write KE equals, okay, I'm going to do 1,000 times 50. Now, if you remember that squaring is multiplying by itself, great. Sometimes people need a reminder, and so sometimes I'll encourage students to just write the number again. So 1,000 times 50 is the same as 50 squared, divided by 2. Okay, so I'm going to take care of all this business on the top first, and I think that that's easier to simplify the problem. So I'm using my calculator right now, so you can type this in with me. 1,000 times 50 times 50 equals, and the number is 2,500,000 divided by 2. Okay, and I'm going to come down here and write my final answer. Kinetic energy, so we have to take that and divide it by 2, is 1,250,000 joules. And you need to do a label on the end of your number. So that is if we're solving for kinetic energy. So sometimes we are given different parts of the equation. In this next example, I'm going to show you how to solve for mass if you're given kinetic energy and velocity. Okay, so I'm going to move my paper up, start a new problem. Okay, I'm going to read the problem to you. We have a toy car with a kinetic energy of 300 joules, and it's traveling along a floor with a velocity of 3 meters per second. So let's write what the problem gives us. In this case, we're given the kinetic energy, and that's 300 joules. We're also told that the velocity is 3 meters per second, and we need to solve for mass. Now we're going to use a different equation. It's a form of the equation we just used, and it's on your cheat sheet. And this equation is mass equals 2 times KE divided by velocity squared. Okay, so just like we plugged in the numbers up here, we're going to take these numbers and put them in down here. So mass equals 2 times, now I'm going to write 300 divided by 3 squared. So you can write those squared, or you can just do 3 times 3. Okay, let's simplify this down. So 300 times 2 is 600. 3 times 3 is 9. Okay, if you want, you can grab your calculator and follow along with me. We're going to take 600 and we're going to divide it by 9. Okay, and we have mass equal to 66.6 repeating. Now, the units on this are different than joules. We're not solving for kinetic energy. In this case, we're solving for mass. So the answer is kilograms, 66.6 kilograms. Okay? So I'm going to do a separate video on the different types of potential energy. You can go back and rewatch this. Okay? If you have any trouble, you can ask. There is one more kinetic energy problem that you had to do in your homework, but it will not be on the study guide or the test, and that's to solve for velocity. So I'm not going to do one of those here.